Welcome back. We have already gone through a bunch of theory about univariate, bivariate, and multivariate analysis, and now we have a good idea of how to deal with different kinds of variables and what sort of inference we can draw from those variables. In this video, we are going to get started with Excel and how we can use all the univariate, bivariate analysis techniques that we have studied so far within Excel. Specifically in this particular video, we are going to deal with how to do basic arithmetic using Excel and how we can extend that same idea to come up with better statistics, more complicated insights, and so on. Well, first of all, this is a little small, so we can just go to the View tab over here and do a zoom to 200% so that our text looks fairly readable. So as you can see, this is the IRIS dataset, which you have seen a few times before. As we know, we have 4 numerical columns in this dataset, and we have 1 categorical column in this dataset, which is the species of a given flower. And every row is basically a sample of the flower, and every value over here is basically the measurement in centimeters of one specific attribute of that flower. So basically for this particular row, what this means is that the sepal length of this particular flower was 5.1 centimeter, the sepal width was 3.5 centimeters, the petal length was 1.4 centimeters, and the petal width was 0.2 centimeters. And this particularly was a Setosa version of the iris. So let's see what we can do with this sort of data. Let's try and get started with some basic univariate statistics. Before we start, we have to designate the first row of our data as the header. You see, Excel yet doesn't know that this is our header. Now, in order to do that, we can just go to the View tab over here and we can click on Freeze Top Row. So when that happens, you see that Excel has frozen the top row, which means that no matter how much I scale, I can always see the top row, no matter how much I scroll. So what that means is that Excel now knows that this is the header of my file. Now, one of the most important univariate statistics that we have is the mean or the average. So let's try and calculate the average of the sepal length column. So in order to do that, first what I'm going to do is need the sum of all the values in this column. Now, in order to do that, we are going to use an Excel formula. There is a special way to use an Excel formula. You see, whenever you are in a particular cell of Excel, you can just start writing anything. So I can type this. This is basically just me writing text in certain cells of the Excel sheet. But if I want to start writing a formula, I have to begin by pressing the equal to key. So basically, this is now going to be interpreted as my formula. So I can just write something like sum of A to A. What that means is that take the sum of the entire A column. This is my A column, and A to A, what it means is that take the whole column into consideration. And then in order to execute that formula, we just press enter. So that's what we know. 805.6 is the sum of this particular column. Of course, if we also knew the exact length of the column, we know that the numerical values start from row number 2 and go all the way up to row number 139. So I can also have a specific range instead of the whole column. So for example, I can have sum of A2 to A139. And you see that we get exactly the same value. But of course, it's not always possible to know the complete length of the column without scrolling down. So that's why we can just use E colon A wherever it applies. Now that we know that this is the sum, so let's call it really sum of sepal length. Let's correct the typo. Now the next thing we need in order to find the mean is basically the count of this particular column. And that can easily be obtained by another formula which is called simply count. Here again, I give it an A colon A because again it just helps me not saves me the trouble of typing the exact coordinates of where the columns are. So that's it. I know that I have 138 rows in my column, and then my mean, I can just call this the count, and let's make a little space so that the values and their names are readable. So this is the sum of the sepal length column, this is the count of the sepal length column, and then the average of the sepal length would be another Excel formula, which I can just say it's equal to this value divided by this value. So what I did was I simply wrote an equal to sign and I clicked on a particular value. Then I typed in the slash sign, which indicates division, and I clicked on the other cell that actually was the divisor. And then when I press enter, that's it. That's basically the mean of my particular column. Now let's try and continue this with the other columns. So let's say I want to do the same thing but for the sepal width column. So I'll just basically do sum of B to B, and then I would just do count of B to B. Well, in this case obviously it's not going to change. Oh, that didn't work. You see, because I did not precede this with an equal to sign, and that's why Excel could not interpret this as a formula. So when I do that, it gives me 138, and then again I simply say that this is a formula which divides the cell which is G5 divided by the cell which is H5, and then I just press enter, and that's the average of the sepal width. Then again I can do the same with the petal length, which is C to C. Then again I do a count and made the same mistake again almost, C to C, and then I just say that this is a formula which is G6 divided by H6. For the sake of completeness, let's also finish this for the petal width column, which is D to D, D to D, and we have a count of D to D, and then we simply have G7 divided by H7, and there it is. Those are basically our average values of all the 4 columns. Now actually, instead of doing each of these steps manually, there is a smarter way to do this. Let us write down the names of our columns over here. So let me just copy these names, and let's say that we type them down over here, and let's say that here I want the sum. So basically when I do a sum of A to A, that gives me my sum 805.86. Now I don't really have to copy and paste the same formula or everywhere else. What I can do simply is drag this. So when I drag this particular formula, you see that it automatically scales to figure out the correct formula substitution for the rest of the columns. And you can see when you click on this particular cell, you can see the formula here. It's basically A colon A. And when you click on this one, you see that it's basically, when you change it, you can see that it's B to B, and then you see it's C to C, and again sum of D to D. So basically we didn't have to manually type down any of these formulae. It's basically all of it is straight away present for us. So all you have to do is basically just take this formula and drag it across. So this is basically called a range selection in Excel. And Excel is smart enough to figure out what are the values over which you're trying to apply a formula based on how far you're dragging it and what is the original formula. So it's pretty smart like that. Now let's say that I have all my sums ready in this particular column. Then I can just do a count column, or in this particular row, that is. Then I can do a count row, which I can simply say as count of A to A. And there it is. And again, as usual, I just drag this. So basically it gives me the count for all columns. And if you look at the formula at the top left over here, it's count of A to A, then it's count of B to B, then it's count of C to C, and then it's count of D to D. And then finally, when I come to the mean, here I can basically just say this is equal to this particular value divided by this particular value, and that's it. That's my mean. This also is draggable. So when I do that, it basically drags to give me the same values as here. So you see, this is basically H12 divided by H13. This is I12 divided by I13, and this is J12 divided by J13. So basically these are my means, and I can very easily calculate them just by filling in one formula and then expanding it to fill all the columns of interest. Now note that this is just an example of how you can use Excel to do basic arithmetic, which is basically sum and division. Multiplication and subtraction also works in a very similar way, and we are going to see examples of that very soon. However, we didn't even have to calculate the mean um, manually by summing and dividing. There is already a formula for mean. As you might have guessed, it's Excel after all. You can just say average. There it is. And you can just drag this over as we know already, and you see that we get the direct values exactly at this. So let's just call this the direct average, right? So that's our average essentially. Let's continue and try to compute the variance also this time. So as we know, the variance is basically you take the average of a particular column, you subtract each value from the column, that average, and then you square that value and take the average of that value. So essentially what this does is that I am basically going to take the sum of a particular column, which is say A to A, or in this case I'll give the explicit range, which is A is to A138. Then I have to basically, sorry, this should be A138. And then I have to subtract essentially the mean. And we know that the mean is this. I have to then square it. So basically that caret symbol means exponentiation. And then I square it to the second power. And then finally I divide it by the count, which is 138. So that gives me the variance of the sepal length column. And again, I can just drag this to include the variances for all the other columns. And of course, this was a variance that we calculated by actually applying this particular formula. Let's take a look at the formula a little more carefully. We took a column, we subtracted the mean of that column, which was present here, and then we squared the column, added it up, and then divided it by the count of that particular column. So that's basically what gives us our mean, our variance. Obviously, there is also a direct formula for variance. There are actually two formulas. One is called population variance versus a sample variance. So in this case, we are talking about a sample variance. So in this case, we can just do A to A. And there it is. It produces a sample variance of 0.69. Looks like we were a little off, but that's because we might have considered the value, the formula that we considered could have been the formula for the population variance instead of the sample variance. So let's try and change this and see if we can actually replicate the same thing with the population variance. And yeah, that's a much closer value. And again, I can just scale this up and that gives me the variances, the directly computed variances of all columns. The last thing that we need to consider is say the standard deviation. So let's just call it STD, and that would just be the square root of this, which we have known since the previous video. So we can just say another formula for taking the square root, which is SQRT, and then you just click the value for which you want to take the square root, or essentially fill in its cell number, and then you finish that. So that's basically the standard deviation. As usual, I can just drag that and there it is. However, as usual, as you might have expected so far, there is also something called a standard deviation, a direct standard deviation. So I can do something like STDEV. Again, since it was a population variation, we can population variance, we can use the variance, the standard deviation value which corresponds to the population. So that would simply mean A to A, and that gives us pretty much the same value. And as you extend it, there we are. So that basically gives us most of the univariate metrics which we can apply on continuous or numerical columns. So these are all the statistical mathematical moments and metrics that we can derive from our data. We had also discussed some graphical ways of deriving univariate analysis, specifically for numerical columns. Those are histograms. So let's see how we can draw histograms. Well, it's fairly simple in Excel. You just select a column and then you go to the Insert tab and say that you want to insert a chart. So this is the area where you're going to find all your charts. Now the chart that we are looking at is a statistical chart, but let's also take a look at what Excel recommends. So this is a button for recommended charts, and you see that it's basically going to give us a bunch of scatter plots, it's going to give us histograms, it's going to give us Pareto distributions. So obviously we want histograms. So let's click on histograms and there it is. That's basically the histogram of sepal length. Let's just move it a little outside so that we can still see everything that's already there. So there it is. I can also click on this particular button here to change, the color of it. So basically it's blue and let's say I want it in green. So I can click on this, it becomes green, and I can edit the chart title. I can say that this is basically the histogram of sepal length. And there it is. That's basically how I can quickly draw a histogram using Excel. If I want to do it for another column, again I do the same thing. I select the column, I go to the Insert tab, I look at either the recommended charts, and if the histogram doesn't show up in the recommended charts, I simply go to the button which corresponds to the statistical charts, which is this one, and I click there and I see that there is an option here for a histogram, and that essentially gives me my histogram for the petal width column as well. And again, I can use a bunch of different styles with these charts. So as you see, we can change the color, but here we can also change the whole style. So let's say I want something like this with a black background and a slightly matte kind of a finish, then this is what my chart looks like. Remember that you can just choose any sort of a slide or a style that you want, and you can use any sort of a color that you want. You can also size these accordingly. You can edit the markers and the titles as and when you like. So that is how you can get histograms out of Excel. So that takes care of all the univariate analysis that we can do on continuous variables, but we haven't exactly thought of what we can do with categorical variables. That is, for example, something like the species column. So let's see what we can do with them. Let's move this entire section of work out of here so that we can basically make some room for our analysis for the categorical data. Now, as we know, the only thing we can do with categorical data in this case is count it. It doesn't support any other operations. Now, in order to count how many different values are present and how frequently they occur, the first thing I need to do is figure out what are the unique values that are actually present in that. So for example, let's say I have this column E, which is the species column, and I want to figure out how many different species are there. If I do a quick scroll, I see that Setosa is there, there's versicolor, and there is also Virginica in some parts of the data set. However, I want to programmatically using Excel find out which are the unique values. So what I can do then is go to the data tab and I can say that I want to do an advanced filter. And when I click on the advanced filter, you'll get this warning, but that's okay. You'll see that you get this window which will let you specify what sort of a filtering you want. So let's say that I don't want to filter the list in place, but I want to copy the output to some other location. So basically, let's do that. And we say that the range is this, and I only want unique records, and I want to copy to, say, a particular file, which is, say, F115. And when I click on OK, that's what I get. I get species, Setosa, versicolor, and Virginica. So now I have the unique species ready under this particular column. So I have species here, and let's also create something called a count. So now I just want to count how many Setosas are there, how many versicolors are there, and how many Virginicas are there. Simple way to do that is to use another formula called the COUNTIF formula. So basically what COUNTIF does is it counts values in a given selection, that is a range. So let's say my range is basically the entire column, which is E to E, and the criteria is basically what you want to match it with, and the criteria I want to be Setosa. What this means is that the criteria is Setosa. So what I mean by this is that count the whole column E to E if any value matches Setosa, and then I can just press enter, and so it tells me that it has 46 columns. Similarly, I can just do a copy and paste it over the new columns, and it gives me 46. So basically here I'm saying that count all the values in species such that they are versicolor, count all the values in species such that they are Virginica. So that's how I get my count values. Now one quick way to basically convert this also into a graphic is to select this data. Let's say that these are my unique species and these are their counts. Of course, in this particular case, it's a balanced data set, so all species are equally probable and equally present. And then again, I can go to insert and I can insert yet another chart. So I can say that I want to create a pie chart. And there it is. That's our chart. We have Setosa, Versicolor, and Virginica all occupying exactly 33% of the pie chart. And that's how we can simply do a counting of the frequencies within a particular categorical column.